293.75 divided by 125. That's the marginal cost of these 125 items. So as we move from 2 workers to 3 workers, our marginal cost is going to be this amount, 293.75 divided by 125. Oh, looks like it's $2.35. I'm sorry, I did do it. So it's the marginal cost is $2.35. Okay, so we're now going to talk about perfect competition. And the way we're going to get started is we're going to review a little bit about the cost curves that we discussed in the previous video. And so just remember, we're going to have our quantity on our x-axis, and our cost, which is going to be measured in dollars, is going to be on this axis. And let's just talk about the average curves for a second. So if you think about average means divide by the quantity. So when the quantity is 0, of course, our averages are going to be sort of in infinity. So it's going to be kind of expensive, and then it's going to fall pretty rapidly, and then average variable cost is going to start to pick up. And then average total cost, of course, fixed cost divided by 0 is part of average total cost. It's way up there, and then it's going to come right down. And then it's going to get, as the difference between variable cost and fixed cost is, excuse me, the difference between total cost, this is average total cost, and this is average variable cost, and the difference between the two curves is going to get smaller and smaller because the difference is average fixed cost. Remember, average fixed cost is just going to be doing something like this. It's going to be going down towards 0. As average fixed cost falls, the difference between average total cost and average variable cost is going to shrink. And so these are going to start getting closer and closer to each other. Okay, and then now we'll talk about maybe in some ways the most important curve in our analysis, which is the marginal cost curve. And the marginal cost curve, we assume marginal cost generally falls as specialization starts to occur, and then it starts to rise again as the diminishing returns effect kicks in. This would be marginal cost. And although I didn't necessarily draw it perfectly, it's going to intersect both average variable cost and average total cost. And the most important one to think about is average total cost for this thing at the minimum average total cost. As I explained in class, if the marginal is above the average, it'll pull the average up, and so the average total cost curve is going to be increasing in quantities greater than where the marginal cost curve hits it. And excuse me, the marginal cost is below the average, it's bringing the average down, and so quantities where the marginal cost is less than the average total cost will be falling. And then it will intersect right at the minimum point of average total cost. So those are the cost curves. Now, these are very important in determining whether or not a firm is going to make a profit and how much that profit is going to be. The firm, of course, is a goal of maximizing its profit. So let's think about, we'll come back to these in a second, but let's think about the total cost curves again. So the total cost curve for a firm is perhaps, well, we're going to have a fixed cost, right? We're going to have fixed cost here, and we're going to have some sort of variable cost, and the variable cost is probably going to accelerate, and then at some point decelerate, and then start accelerating again. And so a total cost curve is going to be parallel to the variable cost. So this is the variable cost curve, this is the fixed cost curve, and the total cost curve is going to be parallel or move exactly the same way as the variable cost curve and be exactly the distance of fixed cost away. I'm not sure if I can draw that perfectly, but let me try. And so this would be total cost. And the goal of the firm, of course, is to maximize profit. We're going to be assuming for the very first part of this course, or this market structure, that we've got perfect competition. So why don't we quickly review what the perfect conditions for perfect competition are. The conditions are that there are many firms, many buyers and many sellers. We're going to be particularly thinking about there being many sellers. Each one of them, no individual seller has a particularly large market share, and the important part is that no particular seller is big enough to be able to affect the price by its own actions. So each seller is a price taker. There's a market price. It can sell as much as it wants at that price. but there's nothing that it can do to affect the price. It just has to take the price that is determined in the market. And so this means that the price does not change no matter how much we produce. How much our quantity goes out, so we're going to have quantity here, and we're going to have, this is our cost, and then I'm also going to put our revenue on here as well. But as our quantity increases, the price is not going to change. We can sell as much as we want at that price. And in a sense, we're saying that the firm, as an individual firm, faces a perfectly elastic demand curve. It can sell as much as it wants at that particular price. So since this is total cost, this is total variable cost, and this is total fixed cost, I'm going to put on total revenue. So total revenue is just going to be price times quantity. And remember, the price does not change as the quantity changes, so it just means that we're going to have a straight line going up from the 0 point. If we sell 0 items, our total revenue will be 0, and then each item we sell at the price. So this is going to be a straight line, and you can imagine it going up. But in here it intersects, and here it intersects, and so the goal of the firm is to maximize profit, which means to maximize the distance between the total revenue curve and the total cost curve. And it turns out that that distance, and you can play around with this at home looking at charts or whatever, it turns out that this distance is maximized when the slope of the total cost curve is the same as the total revenue curve. That's the point where the vertical distance is going to be the greatest. And so you can think about a tangent line here, parallel to the total revenue curve along the total cost curve. It's that point, this particular quantity, straight down, this is the quantity, I'll call it Q star, where profit is maximized. And the slope of the total cost curve, of course, is the marginal cost. And so we want to find the point where marginal cost equals price. That is the point where the firm is maximizing its profits. Now, think about it. We're not trying to maximize our profit per item. We're just trying to maximize our total profit. And so this actually kind of makes sense when you think about it. If let's say we are selling an item for $5 each, and the first item that we make costs us $3. So it costs us, our total cost is $3. We can sell it for $5. Great. We're going to sell that item, and we're going to take our $2. Then the next one we sell, remember there's diminishing returns, we've got to hire a worker, the cost per item may be going up. So the second item we make, maybe that's going to cost us $4. But we can still sell it for $5. Well, do we want to do it? Well, of course. We're going to make it for $4, we're going to sell it for $5. And our profit, of course, our first item we sold for $3. It cost us $3 to make it, we sold it for $5, so we got the $2. And then we sell the next one for $4, we sell it for $5, we get another $1. So now our total profit is $3. The first item cost us $3 to make, the price is $5. So the profit for that item is $2. The second item, it costs us $4 to make. The profit for that item would be obviously $1. Let's say the third item costs us $4.50 to make, so that profit would be 50 cents, but we would still want it because we would rather have $3.50 than just $3. And maybe say the fourth item costs us $4.75 to make, our profit would be $25, so the profit from the 4 items would be $3.75. We would rather have $3.75 than $3.50, and so we would make that item. And then let's say the fifth item cost us $5.10 to make. The profit would be -10. Well, we're not going to make that fifth item. We'll just make 4 items, sell them for $5 each, and we'll move on. As you can see, this marginal cost, as it gets closer and closer to the price, we're going to still produce, and then as soon as we hit that price, we're going to stop, because if the marginal cost goes above the price, well, there's no point in making that additional item. If we make that additional item, it's going to cost us more to make it than we can sell it for. Remember, we don't get to set the price. We just have to accept the price that the market is giving us at $5. And so we will make items up to the point where the cost to them, cost to make them is $5. But beyond that, we're going to stop. And so this idea that we're going to maximize profit where the marginal cost equals the price, it really, really makes sense. I guess I started to review them and then I got so excited that I moved on to something else. So again, let's talk about the conditions for perfect competition. We have many buyers and many sellers, in particular many sellers, each of whom has a small market share and has to accept the price. Secondly, each producer is making a standardized product or a commodity that the consumers do not differentiate the product of one producer from the product of another. And then the third condition, although it's, well, I'm going to call it a condition. The third condition is easy entry and easy exit. And the book says free entry and free exit. That's fine. That's a great term. We're going to talk, when we look at the other market structures, about what barriers to entry and exit there might be that would prevent perfect competition. So I'm not going to get into a whole detailed discussion about what we mean by free entry and free exit. It's actually easier to think about that once we have seen examples where it's not possible. But for the sake of this discussion, just assume that it's true. Firms can enter, firms can leave anytime. And so let's think about, we have one of our firms in our perfectly competitive market. It has a average total cost curve that looks like this, and it has an average variable cost curve, and it's got a marginal cost curve, and so this is the quantity that the firm is making, and this is the price. It's actually all of the dollar variables are going to be on the y-axis, both costs and, you're going to see in a moment, the price. And so as I mentioned, the firm is a price taker, which means that somewhere out there is a market where we have a demand and we have a supply, and we have a price and we have a quantity. And so the market determines the price, and we've discussed about that at some length in this course. And so the price, our firm sees the price. So this is that perfectly, so the demand curve in the market slopes down according to the law of demand, but for the firm itself, it sort of sees this perfectly elastic demand curve, and so it can sell anything that it wants, as much as it wants at that particular price. And as I mentioned, it is going to choose the quantity in order to maximize profit. And the way to choose the quantity to maximize profit is it finds the place where the price equals the marginal cost, and that's our quantity, Q star. And so that's where the price equals marginal cost. The profit is the price, which is also the average revenue. It's also the marginal revenue. The price is all those things in perfect competition. So the price times the quantity, remember, is total revenue. So total revenue would be this rectangle. Our price, which is here. Our price is this distance along the y-axis. Our quantity, of course, is our distance along the x-axis. So the price times the quantity is our total revenue. Profit equals total revenue minus total cost. And, of course, our total cost is going to be our average total cost times our quantity. So we're going to go right down to here. This is the average total cost at our quantity. We're going to draw a straight line over here. And so I'll shade this part in red. This is our total cost. Average total cost at the quantity we're producing times our quantity is our total cost. Our total revenue was that much bigger box. And so our profit, which I guess I'll show you here in green, our profit is the total revenue minus the total cost, or it's this rectangle. You go straight from the price at the quantity that we've decided to produce, straight down to average total cost, go over to the left and to our y-axis, and this box here is our profit. Assuming, of course, that our price is above our minimum average total cost. Now, notice we're not going straight down to that minimum average total cost. The minimum average total cost is over here, as I mentioned, where marginal cost equals average total cost. So you'll notice there's a little bit of white space here. We're actually going to, the average total cost at this point is actually a little bit above the minimum, but it is the idea of the price being above this minimum that allows a profit to happen. And once it's above that minimum, the profit can happen, and then we can decide which quantity is it that we're going to do to produce to maximize that profit.